Many engineering students struggle to find an ideal place to study. Traditional libraries are often overcrowded, and home environments may lack the necessary quiet and focus required for effective learning. This challenge is particularly acute for those studying industrial automation, where practical experience with tools like Programmable Logic Controllers, or PLCs, is essential. To address this, an innovative learning space was established, offering a free, accessible, and comfortable environment tailored to students' needs. This center provides essential resources such as PLCs and advanced software environments like the TIA portal, fostering both individual concentration and collaborative learning. Regular workshops and expert seminars further enhance the learning experience, ensuring students gain the skills and knowledge needed for their academic and professional success. And here's why that matters. By bridging the gap between theoretical knowledge and practical application, this environment not only improves academic performance but also prepares students for real-world challenges in industrial automation. Understanding the role of PLCs in industrial automation education is crucial. PLCs, or Programmable Logic Controllers, are the backbone of modern automation systems. They allow students to translate theoretical concepts into practical applications. Imagine a PLC as the brain of a machine, making decisions and controlling operations based on predefined logic. This hands-on experience is invaluable. It bridges the gap between classroom learning and real-world application. By interacting with PLCs, students gain insights into how industrial processes are automated and controlled. They learn to program, troubleshoot, and optimize automation systems. This practical knowledge is essential for any aspiring engineer in the field of industrial automation. Now, let's dive into the practical implementation of setting up PLCs for your industrial automation projects. First, ensure your PLC is properly connected to your computer via Ethernet or USB. Once connected, open your TIA portal software. Navigate to the Devices tab and add a new device. Select your specific PLC model from the list. Next, configure the communication settings. Set the IP address if using Ethernet, or select the appropriate USB port. Ensure the baud rate matches your PLC's requirements, typically 19,200 for most models. After configuring, click Download to transfer your program to the PLC. Remember, the success of your setup hinges on these precise configurations. Mismatches in settings can lead to communication failures, so double-check each parameter. And here's why that matters. When you dive into TIA Portal, you're not just programming a PLC, you're simulating real-world industrial automation scenarios. Start by creating a new project. Navigate to the Project menu, select New, and choose Standard Project. Name your project and select the appropriate PLC model. Once your project is set up, you'll work within the hardware and software configurations. In the Hardware tab, define your PLC and any connected devices. In Software, you'll write your ladder logic or function block diagrams. Remember, the Online and Diagnostics tab is your go-to for troubleshooting and monitoring real-time data. For simulation, use the Simulation mode. This allows you to test your logic without connecting to physical hardware. Set breakpoints, watch variables, and step through your code to ensure everything functions as expected. This is crucial for catching errors before deployment. And here's why that matters. Advanced PLC programming isn't just about writing code, it's about optimizing every parameter to ensure peak performance. Let's dive into some expert nuances. First, consider the use of structured text over ladder logic for complex algorithms. Structured text allows for more efficient memory usage and faster execution times. Next, think about the importance of minimizing cyclic time. Set your scan cycle to the lowest possible value without compromising functionality. This reduces latency and improves real-time response. Also, employ bit shifting techniques to manipulate data more efficiently. For instance, shifting bits to the left multiplies a number by 2, which can be crucial in high-speed applications. Remember, the trick is to balance readability with performance. Lastly, Don't overlook the power of commenting your code. Clear, concise comments not only help others understand your logic but also serve as a reminder for your future self. This leads us to one of the most crucial aspects of mastering PLC projects is understanding common pitfalls and effective debugging techniques. Let's dive into some frequent issues you might encounter. First, ensure your I/O addressing is correct. Misconfigured addresses can lead to malfunctions. Another common issue is timing problems. Make sure your scan cycle is optimized to avoid delays. When debugging, use the trace function to step through your logic. This helps you identify where the problem occurs. Also, pay attention to error codes. For instance, error 16 number 0041 typically indicates a communication issue. Lastly, always comment your code. This not only helps others understand your logic but also aids in your own troubleshooting process. Remember, debugging is an iterative process. Patience and meticulous attention to detail are key.